8.1, scale drawings. I can use scale drawings to solve problems. So scale drawings are a proportional two-dimensional drawing that is similar to an actual object. It can represent an object that is smaller or larger than the actual drawing. So you can think of this as taking a photo, right, that scales down a person in real life. You can then take that photo and make it different sizes, right? Wallets, 8x10s, blow it up to a poster. So scale drawings are all of those replicas of other things, okay? But they have to be proportional, meaning we can't just change it however we want. That's like when you drag a photo only by the sides or the tops, you know how it gets weird and wonky. That's not to scale. But when you grab it from the corner and you pull and everything changes, that's when it becomes scale, because you're changing everything by the same amount, not just the width or the length. It's everything, okay? So a scale drawing gets changed by what we call a scale. It's a ratio between two sets of measurements. Ratio between two sets of measurements. Cross that part off. So for us, our scale is going to always be that drawing compared to the actual object. Okay, so whatever the drawing is, it's going to be compared to the actual. So that's what our scale will always be. So an example of a scale drawing is, as you can see in this picture, is a blueprint. A blueprint is a perfectly scaled down replica of a house or a building, because if it's not, then when they go to make the actual object, the house, the walls, the measurements, if they don't do it perfectly to an exact scale, then we know how the walls won't match up, or the stairs won't fit, or the plumbing will not be in the right place. So blueprints are just another example of a scale drawing. So in this one, for every 4 inches in this blueprint, okay, in this one right here, there is 3 feet in real life. So if we were going to write our scale, we would write it as 4 inches for every 3 feet. This is our scale. Remember, we always take our drawing over the real thing. And it says right there, 4 inches in the blueprint, that's the drawing, 3 feet in real life. So what we're going to do is we're going to fill out this table so we can find out what these two measurements are in real life. So they have started the first one, 4 inches, 3 feet. They did the second one, 8 inches, 6 feet. So 12 inches would be 9 feet, right? We're just going to go up by 3 feet. 16 inches will be 12 feet. 20 inches will be 15 feet. And then 24 inches will be 18 feet. And so the point of that is that if we need to take this blueprint, we will know that this 24 inches really stands for 18 feet. And this 16 inches really stands for 12 feet in real life. And that's how you would use a blueprint. All right, so we've got a game room. It has a floor that is 120 feet by 70 feet or 75 feet. Okay, so that's the real measurements. A scale drawing of the floor on a grid paper uses this scale, 1 unit. So grid paper is like graph paper. It's those little boxes. Okay, so 1 unit meaning 1 box. One side of it equals 5 feet. What are the dimensions of the scale drawing? So we have our scale, right? So 1 unit, can't even spell when the word's in front of me, unit for every 5 feet. We want to find out what that is on the scale. What is it on the grid paper? So what we're going to do is we're going to set up a proportion. So remember how they said this is what these are, they're proportions. Let's do the 120 feet first. Oops. So what we're trying to find out is the scale. Since I don't know the scale, I'm going to put a variable x, but I do know what it is in real life, 120 feet. So this is our proportion. So for a proportion, there's two ways we can solve this. We can either decide 5 times what gets me 120, and then what we'll do is just like a fraction, we would multiply the top by the same number. Or we can solve it by using a cross product, which is the most common way to do this. So we're going to go across like this. This is a cross product. So 1 times 120 is 120, and 5 times x is 5x. I apologize, I'm drawing this with my fingers. So we're going to then solve this one-step equation. So we're going to divide by 5. And if you notice, we're doing the same thing as what I said at the beginning. We're finding out what times 5 gets us 120. So it's the same process. The reason we use cross products more often, though, is because that way, no matter what we get, we always will get the right answer. No matter what they are, we can get the right answer. So when we divide 120 by 5, that will then tell us the measurements on the scale. So this gets us 24 equals x. So 20 feet, 120 feet in real life is 24 units on grid paper. Okay, that's what that means. Okay, so what I'm going to do is I'm going to set up the other one. I'm going to put it over here. I'll even do it in a different color. So we're going to do, let's say y over 75. And what I want you to do is I want you to figure out what is y. What is the other measurement? Okay, and then we'll go over that later. Okay, so find out what the other measurement is for the unit. What is y? Use a cross product, multiply here, okay? All right, so finish that up, pause, finish that problem up, and then when you're done, you can move on to the next problem. All right, so the art class is planning to paint a mural on the outside wall. The figure is a scale, so this is the replica. What is the area of the actual wall? So the first thing we have to do is find the measurements of the actual wall, right? So here's our scale right here. Okay, there's our scale. So 2 inches for every 3 feet. Okay, so we need to first find, let's do the length there. Let's do 28. This is, remember, the replica, so this is going to go on top this time because that's the replica, and then we want to know how many feet is that. So I'm going to use my cross product. I'm going to do 3 times 28, and we will get 84 is equal to 2x. Okay, so then we're going to solve this one-step equation by dividing by 2 on both sides. And we're going to get 84 divided by 2. And you would get that this in real life is 42 feet. Okay, so that in real life is 42 feet. So now we're going to do the same thing, but with the 11. Okay, so I'm going to take my scale, 2 inches and 3 feet, and we're going to do it with the 11 inches. And again, I'll call it y this time, y feet. Okay, so this time we're going to have 33, right? Cross product equals 2y. Same thing, I'm going to divide by 2. And 33 divided by 2, this is 16 and a half feet in real life. Now, that's not the only thing that question asked, right? Like the last question, it said, what are the actual, or what are the lengths? Now it's asking us for the area, okay? Area is length times width, right? That's my cursive L, length times width. So now what we're going to do is take our two measurements, 42, and times it by our 16.5, and that'll get us our area. So 42 times 16.5 is 693 feet squared. And there's our answer. That's the area. All right, so the next question says the drawing plan for an art studio shows a rectangle that is 3.2 inches by 6 inches. This is a drawing plan, so again, just a plan. The scale in the plan is 3 inches for every 5 feet. Find the length and the width of the actual studio. So this is similar to the problem above, except it's more like a blueprint. It says find the length and the width, and then find the area. So this is the same type of problem as up above. So I want you to pause here and try setting up the two ratios and or proportions and solving for the length and the width. Once you do, push play, see how I did it and see if yours is comparable, and then maybe pause again and find the area and then push play. All right, so I take my 3 over my 5, and I'm going to do it with my 13.2. Again, I'm going to use X. So cross product, I get 3X. Now notice this time I put the 3X first. It really doesn't matter which one you put first, as long as you always set them equal to each other. So 13 and 2/10 times 5 gets us 66. All right, we're going to divide by 3, divide by 3, and we should have gotten that X, in this case, I'm going to put it up here just for space, is going to be 22 feet in real life. Okay, so that's one of the measurements. So then we do it again. 3 over 5 equals 6 over y. Now, this one's a little simpler. I can actually just times by 2. 3 times 2 is 6. So 5 times 2, y will get us 10 feet. All right. So that's how you would do it if you didn't set up a proportion. I only did it that way for this one just because it's very simple. If you did it the other way, you do 5 times 6, 30, 30 divided by 3, 10. Same idea. Now that I have my two measurements, I need to multiply them together to find that area. And so 22 times 10 is 220 feet squared. And there you go, there's your area. All right, so things to remember. Definitely a main one is that it's always drawing over actual. Okay, always, always, always. It's really important that we do that because if you flip that over, it's going to mess up your whole ratio. They always give it to you as drawing over actual. Okay, and then use cross products. Would be the other thing that has to be remembered, using cross products. Okay, that's the multiplication like this. All right, so here's your independent practice. Just so that we're all together, let's just call this the length and this the width, so that when we answer, we all have the same thing. And then don't forget, area is equal to that length times that width, but after you solve for them, okay? So the plan of the terrace is shown at right. The scale is 2 inches to every 6 feet. What are the length and width of the terrace? And then find the terrace's area. So again, this is a plan, like a blueprint, and you're finding the actual. All right, until next time.